Welcome to this AI Sprint demo video for Scone, which is one of the security tools we use in order to increase and ensure confidentiality and integrity in AI workloads. My name is André Martin and I'm a senior researcher at TU Dresden. So let's look first at the design workflows that we have in AI Sprint. In AI Sprint we have an application developer who writes his code. And in addition to writing his code, he or she can annotate his code with so-called security requirements, which are put as annotations into code. Once the code has been annotated and is being piped into the AI Sprint runtime during the design workflow, then we have the Toskerizer and the AI Sprint design tools which actually extract these annotations and regenerate YAML files of it. The YAML files will then be piped into the Toskerizer, which generates a Docker container, and in addition to that provided to the Sconeify CLI tool, which then transparently transform a native Docker image into a secure Docker image, which then can be deployed on an infrastructure which is publicly accessible and which has several tenants that share the same infrastructure. So what are the problems that we solve with the Scone security tools? First, we allow a secure execution of AI workloads which can then run in public and shared computing infrastructure. And this is based on the annotations that were provided by the developers. Furthermore, we allow an automated transformation of these native applications into confidential ones within the AI Sprint deployment flow, so there is no extra effort needed. And we have the automated testing, attestation and configuration of these applications in order to enhance their security. The motivation for this is we want to secure and utilize these trusted execution environments such as Intel SGX, which is of course a complex task since there exists a plethora of existing frameworks which are very complex to configure and to use. Furthermore, the motivation is that we want to ensure confidentiality and integrity, which are usually a must for medical applications, such as when we work with these highly sensitive data. So what are the Scone main contributions? So without AI Sprint, then we have usually applications that run on shared infrastructure where a malicious user with root privileges could, for instance, inspect the memory, so could perform a memory dump and then use this highly sensitive data. Utilizing TEE frameworks that exist since 2016 are very hard to use. For instance, Intel SGX requires rewriting the application as well as recompilation in order to instrument the application, which is hence a lot of manual effort. Furthermore, there is no way to do an efficient secret provisioning, so this must be done manually, which poses, of course, the risk of leaking sensitive data. With AI Sprint, we have the Scone runtime, where we utilize TEEs if they are available, such as Intel SGX on the running node, such that the application runs then in a secure compartment, so in an enclave in an isolated manner, such that even users with root access cannot access the application or perform memory dumps anymore. Furthermore, Scone allows an automatic transformation of these native Docker images into confidential ones, using the Sconeify image approach, hence no manual effort is needed anymore. Furthermore, with the configuration and attestation service that we created, we can ensure that the application runs on trusted hardware as well as we have an efficient way of secret provisioning for keys and as well secrets, such that only these sensitive data items are only provided to trustworthy components. In this demo, I will showcase or I will leverage the mask detection application, which essentially consists of the following two components. We have the blur faces components that extracts the frames, including the faces from the videos, as well as the second component that performs the mask detection. Both of these components are provided by Docker containers, and we will enhance the security by transforming these native Docker images into confidential ones. I will now show a demo on how we do this sconification. So this demo shows how we convert a native Docker image into a confidential one using the Sconeify CLI tool. So we will use the security annotated config files, which are provided as YAML files. And then we will show the execution of the Sconeify CLI tools, which generates then the Scone policies as well as a Docker file in order to then get a secure container out of it. So first we ran our attestation service, so the local attestation service, which is part of the CAS, the configuration attestation service, which is needed in order to then submit the policies. This is the code that we can see. We have here the main application as well as the security annotations that will then be parsed out by the AI Sprint design tools in order to provide specific command line parameters in order to run the Sconeify tool. The Sconeify tool is here being executed. We use the SGX device in order to ensure that it runs in an enclave. The Sconeify tool itself attests itself to the CAS so that it runs in an enclave as well. There are namespaces created. There is an encrypted Docker file or Docker image being created. And then we can see also the output of the Docker file, what it looks like, so what it creates for the user automatically. And we can see there's a Scone signer which transforms the applications executable into a secure application, so signs the application such that it then runs in an enclave. The application process or the confirmation process takes of course some time. Once it has been completed, we can see here the policy that it runs in hardware mode, so it uses Intel SGX. We can also see that it uses here file system encryption, and then when we run the process we can see that it leverages Intel SGX, and the Python process runs here in an enclave using the latest one. We also received the code, so we can also ensure, or we can see that the application has been properly attested. And this concludes the final demo of this video. Then here are the references, and if you have more questions, please contact us on the AI Sprint website. Thank you for watching and listening.